Thank you for the introduction. I appreciate that, Loki and Bruce. Thanks for inviting me to address you today. So, as per the introduction, I'm of the opinion that polymers is a stunning material, and it contributed to the quality of life of all individuals, arguably more so than any other material. The thing is, how do we utilize polymers sustainably? So when Loki approached me, he said, come and tell us what prices will do in the next several years. So thank you for that, Loki, putting me on the spot. Appreciate that. However, so what I thought to do was to give you an overview of the global polymer industry, because as you all know, polymers is a global industry. Today, around about a little bit more than 300 million tons of polymers are being produced and consumed and used on a global basis. South African polymer production, if I include PET and PVC, is around about 1.4 million tons. So compare that to the 300 million tons globally. We need to follow global trends. It's a global industry. So the slides that I want to show you have a lot of detail on them. What I will try to do is to tell you a story rather than go through the detail thereof. So what I would like to cover today is to give you a global economic overview, and we will try and use the data from IHS Markit, which belongs to SP Global, to give you a forecast of what the world, the polymer world, should look like going into 2030 and beyond. The next item that I will discuss is actually polyethylene and polypropylenes, and we will talk about recycling as well. So, I have been fortunate enough to visit the IHS Markit Global Conference in March of this year. And congratulations to Impact for all the people that you have in the room. It's just stunning to see so many people being around and talking about things that they found passionate. So in the Global Conference in Houston, it's the first time that we have had that in around 2 to 3 years, had around about 1,400 people in the room. And all the CEOs of the major polymer producers was there. Argument's sake, you know a small company called LyondellBasell, turnover $4 trillion. He was in the room. So these guys actually shared with us how do they see the war on polymers and the industry going forward, looking at 2040, 2050. So on the board, the amount of disruption and changes that the polymer industry have experienced in the last 5 years, more severe than what we have seen in the previous 3 decades. And I don't have to tell you all the data associated with that. So, traditional feedstocks and the energy market. I will come back to that a little bit. Green petrochemicals and the drive for net zero relative to virgin hydrocarbons. Greenhouse gas emissions and the drive for that as well. And you know, until Biden have come into office in the US, when they signed the treaty on greenhouse gases, globally nothing would have happened. You have to have China in there and you have to have the US in there, because those are the 2 major emission kind of countries. So there's a significant drive towards that, and I will spare a few thoughts on that as we go forward. I don't have to tell you about supply chain. We have had several speakers that were speaking about supply chain. About 18 months ago, you could have imported HDPE out of Singapore. It would have cost you $35, $45 per metric ton to land it in Durban. That number today, $210, $230 per metric ton, have escalated just about 8 to 9-fold. COVID. Who would have imagined 3 years ago that a government can tell people in South Africa, in the UK, in Europe, in the US to stay at home? Who could have imagined that? And obviously all of that have changed spending and consumer behaviorism significantly forever. Pace of capacity investment, I will share that with you as well. And then obviously circularity and how this affects us. So, you don't have to go through all the detail. The next slide is actually only there to give you an indication of global GDP. And you would see that normally it would have sit at around about 2.6% on a global basis, country specific. And then we have had COVID come 2020. It was minus 3.7. This or last year and this year, we're actually in the point of recovering. And it is estimated that come 2023, the world would have caught up with the deficit in growth. We are actually estimating inflation rates for the US and Europe to be in the area of around about 6 to 7%. That is a risk for us, because if inflation starts to run away, consumerism will change as well. So this is the assumptions. You will also see, interestingly, during COVID, the only country in the world that have had positive growth, apparently, was China. We just thought that we are off COVID. Omicron, I've heard globally they call it Omicron. So we were in Omicron, and then what happened? Global tensions, which was predicted at one point in time. So the war against Russia and the United States. Russia and the Ukraine. And obviously, United States, together with the rest of the world, reacted to that, and they started boycotts. So our industry, the raw materials for our industry, is energy cost dependent. Okay? Russia produced around about 7,500 million barrels of oil per day. You have seen, relative to boycotts, first of all, they have boycotted Russian coal. The next thing is oil, and the last thing that will happen is actually gas. But in the scenario that I'm showing you on the board is, if nothing happens, the bottom one, the red one, if there was no boycotts, that is what oil price would have been. So, Loki, to enable us to predict polymer prices, you need to be able to predict oil prices. Okay? The next one that's up there is, I think it's a purple line, it's called a rupture. So there will be some boycotts that's effective relative to oil production from that part of the world, and it will reduce the volumes to around about 4,500 million barrels per day. Full stop, you will see oil prices run away completely. The rupture scenario is not that unrealistic, because oil prices at one point in time was very close to the 130. It's coming down. We are sitting at around about 100, 110. So that's the scenario that we utilize to predict the input costs that actually relate back to the polymer cost. And you can come back and you can say, okay, South Africa is different. Sasol uses coal. Yeah, that's interesting. Around about a year ago, the price of per metric ton of coal was around about $85 per metric ton. Today, it is north of 300, 320. Anyone today that uses coal as an input, either Sasol or Eskom, according to my estimations, will lose money. They can't make money. Input costs have tripled. So let's talk about polyethylene. So what I want to show you in this graph, I know that there's a lot of data in it, but the one on the left-hand side is actually year-on-year polyethylene demand growth. And you can see that the average demand growth over the period from 21 to 25 is around about 3.9%. All that I'm trying to say with this graph is demand growth will outstrip GDP. GDP globally is sitting at around about 2.8. So, polymers, still a stunning place to be. Okay? And then also, coming back to polyethylene, so you will see there's a lot of capacity that's coming on stream between 21 to 25. The blue line is the operating rate, so plant operating rates will actually decrease. So guys like us, most probably going to lose a little bit of weight, right? Profits will be thinner. But on the other side, what you will also see here is there is not a significant change in the application of the polymers, which is depicted by the different lines that's actually there. Not a significant change to be predicted up till 2030. On these graphs, Loki, and I've decided not to do detail on pricing, but just to give you the trend. If we follow the assumptions for oil, on the right hand, and this is polyethylenes, on the left hand side, you will actually see, because in our world, if you have a plant, you have to run it at maximum capacity. That's the only way to actually make good money. if your operating rate, if you don't utilize the capacity of your facility, you're actually going to lose money. So you can see on the left-hand side that the operating rate is going down from around about 88% to around about 82%. That will happen somewhere in 25. So the profitability in our lives will come down in that time span. I will share more detail on that as we go along. On the right-hand side of the graph, you will actually see, on the top part, you will actually see the prices. And in this case, we have actually plotted the prices for China, for the US, and for Western Europe. So Western Europe is the black line, US is the gray line, and then China is actually the blue line that you have in there. Interesting to note on this graph is if you take a look at where we are today, 2022, the disconnect between Western European prices and China prices is at an all-time record. The delta between China prices and US, Western Europe prices, as per that graph, is an easy $700 to $800 per metric ton. We have never seen that before. That's the biggest that we have ever seen. However, like all predictions, forecasts, okay? So they are saying forecasting is very complicated, specifically if you want to do that into the future. So the only thing that I can tell you for sure is that the forecast is wrong. But forecasted, normality will return to the world going forward. But that depends on quite a few assumptions, specifically relative to what is the assumption for Chinese growth going forward. I will show you the numbers. So, on polyethylene, who are the major producers in the world and who are the major importers in the world? As I've said before, polyethylene in totality, just polyethylene, around about 200 million tons of polyethylene being produced and consumed globally. South Africa, between Safripol and Sasol, we have most probably around about 450, 500,000 tons in place. So relatively small relative to the global consumptions. You will see on the graph, big exporters, North America in AM and the Middle East. And where does that material go to? It goes to NEA. That's Northeast Asia, which in principle is China. China is the importer. They import from the Middle East and then from the US. The US normally supplies Europe and South America because there's better prices and volumes to be had in that area. The interesting thing that I want you to note is take a look at the imports for Northeast Asia from 2020 to 2025. It stays around about flat. So Asia will build plants to feed their increased usage due to their GDP. That is estimated at 5.4%. I will share some of that with you in a bit. Okay, polyethylenes. I've said that the profitability in our part of the world will actually reduce in the next 3 to 4 years up till 2025. And why is that the case? Because there's an overbuild to the tune of around about 10 million tons in the next 5 years. Overbuilt 10 million tons. So capacity will outstrip demand by 10 million tons in the next 3 to 4 years. After that, normality returns and profitability should improve. And that actually explained 2 or 3 graphs ago why prices go down and then come back up very strongly in the future. So that's the forecast. While I was in the US, we've talked about circularity, and we've talked about no new virgin hydrocarbons being used in this industry. And there's a global drive for all of that. And governments, specifically in the US as well as in Europe, have carbon taxes in place, there is polymer taxes in place and all of that. Okay? So when they develop new projects, you can build a new complex, a polymer production complex that is carbon neutral. Increase in capital, around about 30%. Increase in operating cost, around about 25%. That's only $1 billion per year. Someone needs to pay for that. So what you can see on this graph is actually they went back to all the guys that have announced projects in the US up till 2022. If the government doesn't give them clear indication of how they will recap the money for the additional capital spent and operating cost spent, they are saying, I'm not building. And that's what you are seeing there. The only project that is announced and confirmed is in 2027, Dow in Fort Saskatchewan, which is a new complex that will be built. I think it's 1.8 million tons of polyethylene, and that will be carbon neutral. But it will cost them $1 billion per year. These guys are saying, if I don't have support for that, I'm not going to do that. Okay? So, what's the bottom line? Even though we have all these predictions on supply demand going into the future, we have seen so much turmoil in the last 3 years. Watch out what will happen next. You never know what will happen next. Okay? Let's cover polypropylene a little bit, and then I will come back to that. Similar kind of graphs, similar kind of methodology that I have. On the left-hand side, you will see the global GDP, around about 3.2% that they have there, and the demand growth for polyprop is actually better than for polyethylenes. It's actually sitting at 4.2 on a global basis. Again, you will see capacity growth over the period of 21 to 25 is sitting at 6.7%. So there's also an overbuild that is associated with that. Where does that come from? And similar to the polyethylenes, you will see it is the guys in China that is building, right? So it is that, what's the color? Red, orange type thing. That's Northeast Asia. It's actually China that is doing all the builds, and no one else as it sits there. Applications, polypropylene, you will see axis on the right-hand side. The operating rate is coming down, but it's not as severe as what you have for polyethylenes. So the prices will be more stable. There should be slightly less volatility in there. And the applications for polypropylene is not estimated to change significantly over the next several years. Again, on the profitability, on the left-hand side, you have capacity and production changes. And then the price on the right-hand side, you will see it's flatter than on the polyethylene part. And the increase is also less steep. So less volatility predicted for polypropylene going into the future. Where's the major producers and where's the importers? So first of all, just to come back to the major producers in the world, in this case, only one, and that's the Middle East. So sitting right there on the oil well, and that is the cheapest raw material that you can find for propylene in the world. And they are basically exporting into India and into Southeast Asia. And you know in South Africa you also find a significant amount of, or you find polypropylene as well as a significant amount of polyethylenes that's actually being imported as from the Middle East. So this gives you an indication why the prices for polyprop estimated to be less volatile than for polyethylenes. That then brings us back to when we started at the second slide or something like that, is circularity and greenhouse gases. So today, there is no virgin polymer producer that can only produce virgin polymers. You also have to be in the space of recycled kind of materials. And as one of the previous speakers have referred to, in my view, arguably, the problem with polymers, it's so efficient and so cheap to produce, there's not enough value in it. So people tend to throw it away. We need to recapture that, and we need to make it circular. To be very simplistic, circularity in polymers can be solved because it's a circular material. You can recycle it, you can bring it back to its original form. That technology is being developed and it exists today already. Not a polyolefin, but if you take PET, you can fully recycle that. You can take a Coke bottle, you can recycle it back to a Coke bottle. It's fully circular. But how do we make this happen? You need chemistry for that. First of all, it's the technical kind of chemistry, like molecules, but it's also the chemistry in between people. How do we handle end-of-use packaging materials? And that's not only true for polymers, it's also true for glass, and it's true for paper. So us, needs to be more responsible on what do we do with the materials that we buy. There's a life for that material. It can be recycled. You don't have to drill a new oil well to produce polypropylene. You can use the packaging material that you have today. And all of us have to get into that. When I was in the US, there were 3 major technology suppliers, Loomis, Technip, and then Kellogg, KBR. Each one of them are spending north of $100 billion in investigating chemical recycling. So if you go back and you are taking a look at recycling technologies as it sits today, the problem with that is you need scale. But the problem with recycling is you can't transport 20, 30, 40, 100, 120,000 tons of material into a site. You lose too much money and your carbon footprint for transport is too high. So the technology needs to develop so that recycling facilities can become modular. You want to recycle at the spot where you have the raw material. That's the most efficient. So these guys are estimating, come 2040, 2050, that I guess is my successor, will have to get into recycling, and at that point in time, a recycling of polymers should be more cost effective than the virgin production of polymers. We are not there today. Today, a recycled material costs around about 25 to 30% more than virgin polymers. That is the technology that we have today. But between 3 companies, $300 billion will solve that problem. Just a high-level overview on recycling, and I'm comparing 2019 to where we are in future. So total polymer demand, call it 300 million tons. You can see how much of that is post-consumer goods, waste, post-consumer waste, mechanical recycled. Small percentages, very small percentages of polymers that's being effectively recycled today. That needs to change. Come 5 years from now, the amount of polymer use will be up around about 46%, and the amount of recycled material will be up significantly, 800%. Mechanical recycled, 92%. Chemical recycled, 800%. We will see the advantages of the investments coming to fruition. So for Safripol, all of us, we need to do mechanical recycling, and I don't have to tell Impact how all of that works. So on PET, it can be done. The technology exists. You can do mechanical recycling. For polyolefins, you do not get back to the original molecule that you have today. However, 10 years from now, that will definitely be the case. So the growth rate for chemical recycling over the next 5 years, or up till 2030, is estimated to be around about 30%, 28 to 30%. That compared to the normal growth rate, in this case of polyethylene, polypropylenes, which is sitting at around about 4%. So there's a market to be had, and we need to keep our eye on technology. This is data from Plastics SA, and you can see since we have had COVID, the numbers, the green part on top is the recycled consumption of polymers, and arguably that's the numbers that I have had. So unfortunately in South Africa, recycling rates is not increasing as it sits now. That is an opportunity, and it's also something that we need to get into and need to affect. So for PET, we are seeing that mechanical recycling will be done. I think it can be done very effectively for Safripol specifically on the PET side. Polyolefin side, we will work with partners to make that happen. I think technology will solve the issue. I think chemical recycling will come towards us. And I think for South Africa, that is one of the ways that we need to solve our waste problem. Not going to spend too much time on this. The trick with recycling in South Africa, so South Africa is an interesting country, right? We have some of the best legislation in the world. And our legislation is normally, or is based on European legislation. So someone previously, I think Loki, have talked about EPR. Did you know that in the UK, there are more than 5,000 registered EPR institutions? More than 5,000 registered institutions. So if you take a look at the South African environment for recycling, it's very fragmented. Similar in the UK. As I've said before, we need chemistry in between people. We need to be able to work together to make this whole value chain work. And in this case, it starts with 55,000 pickers that is working on the streets, that is looking in your waste bins, that is collecting polypropylene or polyethylenes or PETs. 55,000 people. They are the collectors that you have there. We do not have a formal collection system as in Europe. We can say that we need one, but it's not going to happen soon. We need to solve the problem. From there, you need to go back into buyback centers, you need to sort it, you need to bale it, and then from there, you can actually go into what we call recycling, which is the green blocks and then the orange blocks. Us as producers, we are very familiar with the last two blocks that's associated with that. The upstream part is not part of our DNA. And that's why I've said before, as producers, as converters, we will need to take hands and we will have to put the chemistry in place between people so that we can work together. Small advert. Loki said I can run at least one advert on the PP side.
This is not a plastic bottle. It's a bird feeder. Repurpose your plastic. It's not waste if you're not wasting it.
And that's how I want to conclude. So we are all in the polymer field. We are all either producing polymers or either we are using polymers. When that material is at its end of its life, we need to reuse, we need to recycle, and we need to rethink. You do not find a 25-liter PP water bottle or container or the thing that you use to buy diesel on the beach. Why not? Because you can repurpose it. No one will throw it away. It has value in it. So why do we throw away the PET water bottle or the milk bottle? Why do we do that? It is the same molecules. It has the same value. Why do we throw it away? So we need to think about the way, as consumers, that we utilize materials. Not only plastics, but also paper, also glass, everything that we are in connection with each and every day. And that's how we will solve circularity. The technology already exists. It's your responsibility and my responsibility to use materials effectively. And as I've said before, and I think you will agree with me, look at all the examples of where polymer goes. There is no one that can argue that this doesn't add to the quality of life or to the effectiveness of the country or to the GDP of the country or our import-export balance. It adds value to you and me. Let's add the value to the material once we have used it. Thank you. Appreciate it.